Hello, I'm Joseph. I wanted to provide a little bit of an update on the ESP32-C6 stuff, and this is kind of like evolving to a lot more than what I was expecting. The final bit here is I can get everything compiled, but now there seems to be some structures that are not properly declared or not declared, at least for my platform. But I want to walk through some other issues I've been running into. Just to recap on where I started with this, I picked this up. I tried to use Wi-Fi, and as I was using Wi-Fi, I was noticing I was getting these compile errors, which is weird. And if you compile again, you still get these missing references or functions that just aren't there. And my solution that I said in my comments from our last video was to go ahead and just force a group of links into the compiling process for the final L file. The ordering actually didn't matter. It was just that there is a tree shaking process that happens, and for whatever reason, libapp-zig isn't a part of that. I don't know how to do that. This person doesn't know how to do that either. At least that's what I'm assuming. So we don't know how to tell CMake to include this into that tree shaking process, so that when libnet 8211 was being included, it's not being dropped off. Because effectively, what's happening is that there's a bunch of functions being called here in my Zig code that aren't being considered, and then things like libmesh, things like net, even though it was in the linking process, was just being dropped out altogether. And in subsequent of me trying to fix this, then all these functions that were being declared shouldn't have been declared in the first place, because they were external to libnets 80211 and stuff like that. So it was just like it was a problem that was there in the first place. They try to sidestep it by manually including just the bare minimum needed to compile this with their Wi-Fi version. And as I worked this a little bit more, I'm like, it's a little weird, but also the size of the lib app is kind of large. It's 100,000 plus bytes in this, before I got the code to kind of um, get to where I'm at now. And I made a remark on that. I'm like, this is weird that we're including every object file in here. So there's static libs, the .a files, and then there's object files to implement the functions that were missing from subsequent other static libraries like the lib 80, 211 stuff. And so what I found was that it ballooned up to almost 300,000 kilobytes for a static library that should not be that big in the first place. To give you a reference, like the C version that I have here that I'm referencing for my code was down to just like a kilobyte plus. So libmain here 1455 versus that 200,000, 280,000 almost bytes here. So it was way bigger than it needed to be. And so what I would did was go ahead and drop out the entire process of including every single OBJ file, because it's not needed. If these are static libraries and because they're not shared, we can ignore undefined functions because we're expecting the other libs to implement it. And so I had to go through and find every single missing function from my example and find the subsequent things to go ahead and also include it into this linking process. That got the lib file down from that 200 plus kilobytes, with release small kind of noted here, for the down to like 6 kilobytes, which I think is much more reasonable, very small for the little bit of work that is being done in Zig. And I'm pretty happy about that. And then the subsequent result now is that when I try to run the thing, I go here and get my code out. Unfortunately, the there is a alignment issue with some of the structs that I can't find right now. And so if I go and open up my app here and look for magic, actually, it was like defaults, something defaults. There we go. So GD. So I added this here, and this is stemming into a whole bunch of other stuff here. But this magic number is required for Wi-Fi to initialize properly. If it doesn't see it, it will not initialize it. And so here it is. It just finished, but it says, hey, the magic number is invalid. You're giving me 5. I want my magic number, but I'm thinking this is the magic number. And when I print it out, where is it at? Magic number. I'm not seeing it offhand. Right here. it's here, 1, F2, F3, F4, F. That's the magic number. It's not 5. And so what I did was I went ahead and changed what I saw here as 5 to this. And as soon as I did that, then it said, "Hey, by the way, your magic number is invalid. It's 6," because I had changed this to 6. I'm like, "Crap." So the issue here now is that ID, um, let's see, fine, IDF sys here. The very top comment about this piece says it's for Extensia. This is the S series of the ESP32 line. And what I'm thinking has happened, because as I was working through it, as I was adding some extra things too in some of the structs that I was working through, because they were just outright, they weren't there. I'm like, oh, maybe it's like an old version. I don't think it's that. I think what has happened is that this person created and a lot of these structs are for Extensia. They're not for the RISC-V architecture. And a bigger issue that's going to happen is he mentioned he wanted to just to automate this. It's not going to automate. The general thing is there's a lot of opaque um, structs here. This here. Let me see. Yeah. So all these opaque structs do need to be eventually declared, and there is no way currently in Zig to kind of like say, hey, by the way, this thing here, override this with this our own struct because it's opaque. This is kind of like the big stick for me and how C translates words. It's either an all or nothing, and even though it's very transparent on everything it translate, you don't have that opportunity to fix some of the really small things that are going to be major later on. And you have to do this adoption where now every single architect, every single variant of it may need its own idea sys with handcrafted solutions around some of this stuff because every time there are, like byte fields here and stuff like that, like it's noting what's being demoted to and all the stuff that just there's no way to do the um, to reference all the C code as Zig code here, like it does. I don't like that Zig does this, by the way. And the reason why I'm saying I don't like this because this is just like every other language. For me, I really bought into Zig because of how easy or great the C import process was, and I found out very quickly it's not great. And this whole thing is being rewritten, by the way. I don't know when this is going to ship in the next version or what version of Zig, but the idea is, in the meantime, what I want to see is a way to be able to interop with C translate for overrides of certain functions that can't be translated properly, to be able to push in our bits that we need fixed that is broken in this C translate. Because anything that is here, there's no idea if any of this actually compiles correctly. It's not until you try to use it that Zig will then subsequently try to compile this, and then you don't know if it's correct. So, like I said, it's telling me it's magic number 5, even though I had the magic number set correctly here as 1 F2 F3 F that type of thing. So my next step here is to go ahead and see if I can go ahead and regenerate this. Now, the guy made a comment here about regenerating this in here for. I don't know um, what what they're talking about, but the reality is we don't want to use C import. And again, because it's going to have a bunch of opaque stuff specifically around Wi-Fi because of how bit flags work, that it can't have automatic C import. It needs handcrafted solutions for each of these architectures. And so that's where I'm at. The reality is a lot of this could be a lot simpler. I could just in my C code include the static lib in my for my Zig and do like little small interops or bridges. I don't need all of this code. Actually, not all of this code, but all this code to actually be in Zig, because there's so much nuance to all the C code. There's no reason for me now to have to take over all this nuance. Like for example, here there's additional things that happen in. I don't know if I can jump to it. Okay. So there's all this additional stuff that happens in the init config where it actually pulls from your SDK config here of a bunch of like Y, yes, no's and some SSIDs and stuff like that. The problem here is that now I'm taking in the responsibility of now having to parse this as well. I need to, in my build file, go and parse this SDK config so I can properly pre-fill it here. And then there are subsequent things that are some of these are per architecture, some of them are general. So if I go to this one here, this is a general Wi-Fi thing, but it does fall if you have this in your configuration, it would use that. If not, the default for it is 0. And so I don't, I would need to recreate all this in my Zig version, which again, I don't see the point in doing. There's no reason for me to do this if the C version already does all of this. And I don't care for my Wi-Fi stuff to be in my Zig code. I just want to do something like maybe some networking thing. The ESP IDF already has a bunch of libraries for around real-time operating system. It has stuff for all this HTTP, HTTPS server stuff that you can do on these things. Has TLS support, has encryption, a bunch of stuff that is really really cool that I can pull from C. But every time I want to do that, I need to make this bridge, which I can just do the reverse of. If I wanted to use HTTP from C, I can build it out in C and just send the handler request to my Zig code and build that separately, and it'll be fine. But for now, I'm just going to try and see if I can regenerate the C translate stuff and recraft it for the C6 version. Um, but it's not looking great in terms of this solution being the solution moving forward because the amount of work is going to take to do this. And like coming from Rust, what I would do to kind of resolve this here is each thing, like if I need Wi-Fi and I need Wi-Fi with these configuration flags, I would go into my cargo file and I would specify this as the cargo import for the dependencies, and it would just do that. It would do it knows kind of like what like somebody has already done all this work, and now all this work needs to be redone for Zig. But also, there's no way to do this in a cargo thing. No, there's no build version that's going to go and edit a CMake thing, interject it into a CMake project, because this is completely separate from your building process. You're making a lib that then gets included anyways, and so all this link library things is inside that final process that IDF handles. And so I don't have a good solution for this offhand other than maybe have it write another CMake that does all of this based off what you are wanting to pick from and what is in the SDK config here to then subsequently pick which of the libs like embed crypto thing that also needs to be subsequently included.